Okay, wow, that was Deep Purple and Speaking. So I don't know why I chose that. I just felt like I was in a bit of a rocking mood this morning. So we've got balancing equations to think about today. Sorry for the slightly delay. We had a few technical hitches with the camera. Just getting the focusing right. It loses a bit of clarity on Facebook, so it is a little bit blurry. But I think we've got enough focus to get the right idea of what is going on. Okay, so this is really an introduction this morning about equations and particularly algebra as well. So when we're concentrating about this topic, one of the things we've got to think about is what algebra is. So first of all, we're going to be using some letters. Now a lot of people get confused about why do we have letters and what's the point of those and why can't we just have numbers. But one of the things and the power of algebra is that sometimes numbers in everyday functions change from day to day. So I'll give you an example. If I'm going to go to work and I'm traveling at a speed, my speed is changing all the time. So I might come to some traffic lights and slow down, so the speed changes. So instead of saying the speed is always 30 miles an hour, which isn't, we can say that speed is S for speed, and that changes and varies. And one of the things we've got to think about here is that if something changes, as well as giving it a letter, we can also call it a variable because it varies. So in that example, S is given a value. Okay, so it could be 30 miles an hour or something like that. But then the next day there's no traffic on the road, so S could be 40. Or the next day S could be 20 because I'm coming up to a traffic light or stuck behind a van. So it does change, these letters change. And a letter in maths is simply a value, a number that we're trying to find out. Now in equations, one of the things we do is we try and find out what that value of that letter is going to be. And when we solve an equation, we find out the value of the missing item, the missing letter, or whatever we've got. So in this case, the worksheet is showing a question mark, but that could be any letter. For example, it could be a W or an X or a Y or whatever we choose it could be. Okay, and that's the basis of what's going on. Now this could vary as well. If we put other things on here or change that value, that can happen. But as a general rule for equations, the letter pretty much stays the same. And our job is for this setup, this system, okay, we need to work out what the value of the missing letter is. And that's different to other areas of algebra, which could be not finding out the letter's value at all. It could be simplifying, it could be using brackets, it could be used doing any of those. Well, let's concentrate on a bit of work on this equations. There's a few examples. Okay, so first of all, I'm not going to do every single question on here. We're just going to use the first one or two to give you an example of what's going on. Okay, so let's have a look at the first equation. The first thing to think about here is that it's like a seesaw. So if you take something away from one side or add something, okay, the seesaw is going to go up or down, and our job is to keep it on the level. Okay, so what have we got here then to help us? Where would the equal sign be? I'm going to give you a second to think about where would an equal sign be for that equation. That's right in the middle. So it's the exact pivot point is where the equal sign is. So what we've got here is a value of 1, 2, 3, 4, 5 equivalent equals to 3 and something we don't know. So how are we going to go about solving that? All we need to do is basically take away these three items here, these three values, unit values, and to balance we've got to take these three unit values away from here. Okay, so what that leaves us is a value of 2 and the question mark. So by taking away certain items on the system, and you've got to do that on both sides, you can get down to what the value of that question mark is. And that's the basis of all equations, to be able to whittle it down by keeping a balance to get the final answer. So we end up with 2 equals question mark. Now a lot of people ask me, does it matter if question mark's on the left or the right? And the answer is no, it doesn't, because in maths we're working from the top to the bottom of the page in sections. The idea of left to right in maths doesn't really exist, because the left part of an equation or the left part of working out is as important as the right part. What does matter is we stick to the idea of bidmas. So we don't go left to right like in English. We use the system of bidmas to help us which bit of the maths to do first, and we work from the top of the page to the bottom, left and right being fairly irrelevant of the order that we go in. Okay, so let's have a look at another one, alright, in a similar system. So this time we can group together the values. So if you have a look at this bit here, we've got a value of 4 there, alright. So we want to get the question mark on its own. So the first thing I'm going to do is remove those 4 items. I'm going to take them away. And what will happen is the seesaw will go downwards like that, okay, because we've taken off weight or value off one side. So to compensate, we need to do exactly the same thing to the other side. So therefore I'm going to take away 4 away from that side. Okay, so what I'm left with is a question mark equals 6. And if we use the highlighter to show us, we've got question mark equals 6. Again, the order doesn't really matter which way we're going. Question marks equal to 6. We're making an equal system. The missing value is worth 6. It doesn't matter if the missing value is there or there. Okay, what matters is we get to that final answer. So let's have a look at a couple more. Alright, so this is another system here. Okay, now I'm going to set up the equation using the symbols, and then I'm going to pause and let you have a think about it for a few seconds. So here we've got 2 question marks equals, and I'm working this way round, 2, 4, 6, 8, 10. Okay, so I'm going to give you a second to think about that, and while you're at it, have a look at this, how I've written it out here for the equation. Okay, that's right. So because these 2 are equal, we can split them in half, take away one of those question marks. We don't know the value of the question mark yet, but we do know that both of these come to all of this. So one of those items is going to be half of this value. So counting these up, 2, 4, 6, 8, 10. There's 10 altogether. So if I split these in half, I've got 5 and a 5. So I'll take away 5 away. Okay, so that will make one question mark equal to 5. I know it's 5 because it's exactly half, and these 2 must be the same. Okay, now I'm just going to whittle down to a bit further down to one of the more difficult ones. So this number 9 here is a good one to have a quick look at. Okay, so this is a 2-step equation, so we've got to do certain things in order. So first of all, I'll just write these out as in an algebraic method. 3, 4, 5, 6 plus question mark equals 3 dots plus 2 question marks. Okay, so we've got to take away various things here. The first thing I want to do is take away this value here, these 3 dots. And then on the other side, to balance, I've got to take away 3 dots there. They're gone. So what I'm left with now is 2 question marks and a question mark and 3. Okay, so that's the first step. We're trying to narrow it down. Okay, so the next step here, oh, by the way, if I write the algebra out now, I've taken 3 away from there, take away 3 from there, I've got 3 plus question mark left equals 2 question marks. Now in this case I want to get one question mark, so I need to find out what one question mark is. So my next step would be to take away a missing value from there and a missing value from there. Now there is one deceiving thing about using question marks, is the idea is that these values are all the same, and if we have a letter it's not saying they're all different, whereas a question mark kind of refers to that they could all be different, but they're not. They're all, these shapes are all the same value. So therefore if I take one of the shapes away, I must take a shape away on the other side. So what am I left with at this stage? I've done equal things to both sides, so it still balances, and I've got one question mark left there, and I've got a value of 3, so my final answer is question mark equals 3. Now notice I'm trying to get this equal sign in line as I'm working downwards to make sure that it always balances. So that's a little hint. You won't be marked down if they're not in line, but it's much better. So let's just take the working out that we've got there and redo it. So we start off with 6 plus question mark equals 3 plus 2 question marks. Oh, one thing I was talking about is that when we've got a number of question marks, we don't put a times, we don't put 2 lots, we just say there's 2 question marks that we need. So what did I do from an algebraic point of view? The first thing I did was to lose 3 from each side. And it's a good idea to keep a running record of what's going on. So I'm taking away 3 from both sides. So 6 minus 3 is 3. I'm not touching that question mark yet, and I'm taking that 3 away. Okay, I'm not messing around with the 2. And you can see already the equation looks a lot easier. So my next job is I've got one question mark there. I don't want that because I want a question mark on one side and a number on the other. So this has got to go. And I'm left with 3 equals, and I only need to take a question mark from here, so instead of 2 question marks I've got 1 question mark, and that's my final answer. I could switch this around because one number equals another, that equals another, so it doesn't matter at this stage. It doesn't matter what's got they're equal, they're the same thing, so you can switch them around. It's not a good idea to switch them around earlier on without using this balancing process. Okay, so let's just have a look at a further worksheet. Oh, that's yesterday's. Okay, here we go. So one last worksheet in a similar fashion. Okay, balancing problems, and I'll be putting these worksheets on the website, on the page, or even Google Classrooms. Okay, so you'll be able to access them at some stage. So let's have a look at the example just to clarify what they're doing. It's exactly the same format, different graphics. We've got an a plus 7 equals 13. Take away 7 from both sides, and I'm left with a on that side. 13 minus 7 is 6. So let's just finish off now with a different format of a question. Alright, so first thing is, let's see what we need to remove. Okay, I've got an a minus 4 equals 10, and I want a on its own. So what do I have to do there to make that into a 0? So if that's a 0, then I've got a on its own. So it's a negative 4 at the moment. I'll give you a second to think about that. Right, that's correct. You need to add 4 this time, because that'll bring that in line with 0. Negative 4 add 4 is 0. That means that disappears completely, and I'm left with just an a. Negative 4 add 4 is nothing, but what I must do is the same on the other side. So that means that 10 add 4 is 14. Now by all means, a good little thing to think about here is go right back to the beginning and see if your number, which I've got as 14, the light's a bit funny there, isn't it, but I've got a equals 14 to the final answer. Okay, so go back to the beginning and just see if get. I'm working on this blurry clarity business. We're going to get it right before long. How's that? Oh, it's a little bit blurred again. Yeah, I think it's the worksheet as well today. But anyway, oh, that's not too bad. So we've got a equals 14 there. Alright, so take that value of 14, go back to the right at the beginning and see if it matches up. So instead of a, I've got 14 minus 4, that makes 10, so that all matches up. And this idea of putting the number back in for a letter, it's, yes, it is another it's another part of algebra, another area of algebra. But having said that, it's called substitution. Okay, and it's straightforward. We just replace the number with a letter. So 14 minus 4 equals 10. Oh, and that's it for today. But tomorrow we're going to meet at the same time, and we're going to take this a little bit further, and we're going to drop the idea of the balanced diagrams, although they are really useful to use, but we're going to drop those and we're going to go into the more detailed algebra where we haven't got that that scale to help us. But you know what, in GCSE, if you're stuck, it takes 2 seconds to transfer your equation into a system like this, and there's no harm in doing that for your working out. Okay folks, that's it for now, and I'm going to leave you with some one of the 3 top rock bands of all time. There's 3 ones that started the heavy metal, heavy rock genre off. So trivia, not related to the equations, but if there's 3 classic bands that started it off, which were those 3 classic bands? This one of them is Deep Purple, and we'll go back to looking at some of that now, just to finish off. Okay, bye for now, see you tomorrow.
You'll see that line that's drawn between good and bad. See the blind man,
Ian Gillan at his best. Yeah. Shooting at the world, sweet child in time. See you tomorrow, folks. Same time, same place.